So example 1 is the easiest type of word problem because you already have the equation. So when you're trying to draw this graph, we have the equation already. We're going to use DAB C. If we're looking at DAB C, what's your D value? 13.7. What's your A value? Negative 4.5. I'm going to just write 4.5 for the amplitude, and we'll think about the negative later as far as whether it starts at a maximum, minimum, or in the middle going down. And then our B value is 0.16. What do we use our B value to figure out? So I want you to take out your calculator right now because there's a very common mistake when typing this into your calculator. I want to make sure that you get 12.5. So 2 pi divided by 0.16 pi is 12.5. I want to make sure that when you type that into your calculator, you're getting that, not a much bigger number. Or a smaller number, or a different number. If you get a different number, then you've done it wrong. And I'll tell you what I think you did wrong. You have to use brackets, or if you have the fraction thing on your calculator, this is a great place. Use that fraction button, go second y equals to get the fraction thing, to type it exactly as a fraction. You won't make any mistakes. If you don't use the fraction and you just type it in, 2 pi divided by 0.16 pi, your calculator will give you a wrong answer because you would need this to be in brackets. Because technically on the bottom there's two things there. There's a 0.16 times by pi. And anytime there's two things in the bottom of a fraction, you would need to have brackets there to tell your calculator that both of those things need to be on the bottom. But it is much better if you have your calculator and you have the option to go, quit alpha, y equals, get the fraction up and write it exactly as you see it, 2 pi divided by 0.16 pi.
What the 0?
The 0 is not necessary. Because if you went like this, 2 pi divided by 0.16 pi, technically what your calculator does is it does order of operations that does 2 times pi. It divides by 0.16, and then it takes that answer and multiplies by pi, and you get a much bigger answer than you should. So our period is 12.5. Now that we've got the D, the A, and the B, we can start graphing those things. Remember, a little bit of thinking here. I'm going to draw my axes like this because my center line is at 13.7. My amplitude is 4.5, so I'm going to go up 4.5. That will get me to 18.2. Down 4.5. That will get me down to 9.2. My period is 12 pi, so I mark 12 pi on my axis. I divide it into 4 equal sections. Half of 12 pi is 6.25. Half of 6.25 is 3.125. And the third one will be 3.125 times 3, or 9.375. Normally we would now graph it temporarily and then do our phase shift. Can you see that there is no shift in this one? There's no C value. So when we graph it, it will be our final graph. Going to graph this, what kind of graph is it? Cos graph, but it's a negative cos graph, so where does it start? Starts at a minimum. So you go minimum to middle to maximum to middle. Whoa, am I a little bit off? Yes. There we go. There. That's better. And so here is our graph. Now, in part B, Part B, there's two methods for solving Part B. One is using your graphing calculator and one is not. We are going to solve Part B with our graphing calculator first because it makes life easier. But you also have to know how to use your graphing calculator in order to do that. So we've got a big boat. It needs 14.5 meters of water in order to come in and dock safely. Otherwise, the water levels are too shallow. So if we go back to our graph and we think about that, can you see that 14.5 is about here? And if we drew a straight line across here, that it's only going to be safe between here and here. In this section is where the depth of the water is deeper. We should probably, since this is a word problem, we should do some labels on here. Our y-axis, that stood for our depth, and it's in meters. And we should label this. This is our time, and it's in hours. So we need to find out how much time is it between here and here. So our graphing calculator solution, if you want your graphing calculator to tell you this, what you need to do is you need to make this graph appear on your screen. That's your job right now. So once you've got that graph on your screen, you can show it to me. You're going to go to y equals, and you're going to type your equation in to y1. And I want the graph to look exactly like the green one here.
Does it have to be the same color?
No, it doesn't have to be the same color. The first thing when we go to put this into our graphing calculator, we've typed it in. Hit your mode button and make sure that you're in radians. So that's our first thing because we're dealing with radians here. We would like all of our graphing stuff that we've done is all in radians right now, with 2 pi over b as your period because we're thinking in radians. So we're in radians. We've typed it into y equals. Chances are a number of you, your window was standard when you started, and you hit graph and this is what happened. And you're like, there's nothing. And then a little smiley face appeared. But it made you frown because it does not match up. The reason it does not match up is because right now, what do you have? As far as the window goes, you have this window. So no wonder you only saw that little part. What we want our window to look like this. So that appears on our screen. How do we do that? We go back to our calculator and we hit the window button. This standard window that appeared goes from -10 to 10 on our x values and -10 to 10 on our y values. When you look at our sketch, can you see that our x values, it might be nice to go from maybe -3 to 15? That's about what I have here. And if I look at my y values, again, we didn't need any of the negative numbers, but if you go into the negatives a little bit, then your axes will show up, which is kind of nice. So I'm going to start at -2, and how high should I go? 20? 20 would be nice. Okay? This will work out nice for our graph. What we can also do on our graph, if we want to be fancy, this XSCL stands for the X scale. Right now it's at 1, which means it's going to have a ticky mark thing at every 1. If I want to be fancy and have these 3.125 show up, I can do that. I can make it go every 3.125, and then these marks will show up perfectly like that. For your y values, you won't have anything, you know, maybe you want to go up by 5s. But now when I hit graph, it looks identical to the one that we sketched. And once you have your graph in there, when we go to part B, we wanted to find out when does it hit that 14.5. We can go back to y equals, and in our second equation, type in 14.5, and that'll draw that horizontal line straight across at 14.5. So we want to find this point and this point. So we have to figure out how to do that on your calculator. All of the calculations you like to do with graphs are above the trace button in Calculate. So if you go second, trace, it gets you to this menu. It lets you figure out values from your graph, zeros or x-intercepts, maximums, minimums. In this case, we want number 5. Intersect. Where do those two graphs intersect? And if I push enter, it'll say, what's your first curve? And it'll have a cursor on one of your curves. You can push enter. What's your second curve? It automatically jumps to the second one. You can push enter. Where do you guess it's going to intersect? I don't know why it asks you to guess, but it always does. I think it's over here. And then you push enter again. Oh, I was off. So at 3.48, so we just figured out that this first one is at 3.48. Where's our second one? We have to go through that process again. So second, trace. You can push number 5 to get to it quicker. Now, if I push enter 3 times, it's going to find the same one again. I have to, whatever your cursor is closest to, that will be the answer. So I need to move my cursor. I mean, if you want to live on the edge, you could try it here. But it's not, this will be enough. Now it's closer to that one. Most people like to get, okay, that definitely is closer to that one. I can push enter 3 times, do the guess, and it's at 9.02. So this one, 9.02. How much time can it safely dock? If we do 9.02 minus the 3.48, it can safely dock for 5.54 hours. Just round it to 6. Yeah, that might not be good. Or just round to the nearest 10. Well, it's closer to 10 hours. So this is how we would do it if we have our graphing calculator. Having this technology allows us to solve it quickly, but you need to know how to use the technology, how to set up your window, how to set up your graph. Now, when you get to university, chances are if they had this type of question on an exam, they would not allow you the graphing part of a graphing calculator. It would be a calculator question. How would we solve this using our skills with calculators? So you're not going to write this down. It's going to be on the video. You can watch it later. I'll show you how you would do this just with a regular calculator using your knowledge, your cast rule and reference angles and all of that to figure it out. So first of all, when you're trying to find out when it intersects with 14.5, that's like telling you that the y value is equal to 14.5. So if I plug 14.5 in for the y value, I get this equation, and I have to solve for t. It's a cosine equation. So you have to ask yourself, how do I solve cosine equations? Well, I get the cos by itself, I find my reference angle, and then I find my angles. So we're going to do that as well. How would I get cos by itself? I'd subtract 13.7 on both sides. I divide by negative 4.5, and I get cos by itself. Now, for the most part, when you get to this point, we don't normally have all that extra stuff inside, right? We normally just have nice equations. Cos of theta, oh, so nice, is this. And so when we have the extra stuff, it's kind of like it feels awkward, and it's more difficult. So as a strategy, one thing that we do is we temporarily say, I'm going to ignore all this extra stuff and just make it theta inside. So I temporarily let theta equal the inside so that it looks like something I'm used to. Now, if I'm solving this, what do I have to do? Well, cos is negative. It's going to be in quadrants 2 and 3. I'm going to need to find my reference angle. Remember, when we find our reference angle, we always use the positive values. So I do cos inverse of the 0.8 over 4.5, and I get a reference angle of 1.392. I then would say, since it's in quadrant 2 and quadrant 3, well, in quadrant 2, I would go pi minus my reference angle. In quadrant 3, I would go pi plus my reference angle. So normally in math, you would now be done. You solve for theta. But our job wasn't to solve for theta. It was to solve for t. So did you see how we temporarily replaced theta with 0.16 pi t? Now that we figured out what theta is equal, each of these is equal to 0.16 pi t. So we can look at the one in quadrant 2. If theta was equal to 1.7495, now we can substitute back, and 0.16 pi t would equal that. How do I solve for t? Divide by 0.16 pi, put that in my calculator, and there's our 3.48, the same number that we got from our graphing calculator. Similarly, we could look at the one in quadrant 3, divide by 0.16 pi, and we get our 9.02. Subtracting those two together, and we get our 5.54 hours. So this would be, you would still need a calculator for this because you need a scientific calculator to do the cos inverse to find your reference angle, and all the pi minus your reference angle and pi plus your reference angle. That requires your calculator. But the graphing calculator solution allowed us to find that quicker if you know how to use your calculator. If you don't know how to use the calculator, the graphing calculator question is hard because you don't know what to do. And you can sit there holding it for a long time and not get any answers. So technology is great if you know how to use it. It can make things faster, which it does in this case. But do you notice in the technology that we still needed to know things in order to use the technology, right? First of all, we needed to know how to sketch our graph in order to set up a window that was appropriate. Okay? I've seen people spend 5 minutes hitting the zoom button on their calculator trying to find a graph, right? Because, you know, there might be a graph that starts at 2,000 and has a slope like this. And they're trying to find that graph, and they start with their standard window that's like this, and there's nothing in it. So they're like, oh, maybe I'll look over here. No, nothing. What about over here? Nothing. And they look for hours just randomly searching.
Check your y-intercept, dummy.
Could do that. In this case, having some knowledge, first of all, what the graph looked like, helped us get our sketch on here. And then we could use our calculator to find other values. So the key buttons we found in here was learning how to use our window button, how the window sets your screen up, and then this menu and second trace, how we found our intersection there, and you can find other things as well.
Mr. Ross,
Yes.